Okay, the last class, I thought we'd move on to the next chapter, but it seems you guys did not understand chapter 7 at all. So we're going to review chapter 7 again, just like a revision thingy, okay? So, first of all, 7.1. The first concurrence rule is SAS. SAS literally means what? So, it means if there are two triangles, okay, separate triangles, and one of the side, let's say ABC, PQR. If one of the side, that is AB, side means AB, right, is equal to PQ, okay, and then another angle, one of the angles, let's say A, angle A is equal to angle P, okay, and then one more side, AC is equal to PR, which literally means this side and this side is equal, this angle and this angle has the same measurement, and this side and this side is of the same length, okay, then we can say that this triangle is concurrent to triangle PQR. If this is equal to this, angles are equal and the sides are equal, and remember it should be like this, okay, side and the angle in between the equal sides, because this side and this side is equal, this side and this side is equal, and this angle is between these two sides, right? So only when it is like that you can say that these two triangles are concurrent, and the concurrency rule is called side angle side, because sides are equal, one angle in between them is equal, and the sides are equal again, so it's side angle side, right? So this is this and this. If you find this kind of equality in two triangles, then you should always conclude that they are concurrent. By the way, concurrent means what? Concurrent means exactly the same, replica, like copy paste. So if triangle ABC and PQ are concurrent, it means that rest of the sides, see, these things are mentioned in the question. Let's say all this stuff, the two sides are equal, the angles are equal, and the two sides are equal, nah? But without even if you know this, suppose they've given us the measurements, okay, if this is 7 centimeter, this is 7 centimeter, this is 40 degree, this is 40 degree, and then this is 8 centimeter, and then this is also 8 centimeter, suppose. So you can safely assume that I have a sorry, you can safely assume that the rest of the angles and sides in the triangle will also be equal to itu QR BC la measurement nilwi. You can say that this and this is also equal. Why is it equal? Because you just proved that these two are concurrent. Concurrent means everything should be equal. So you can say that this, without even knowing the measurement, and this will be equal, and then this and this will also be equal. Got it? Without even knowing the measurements, you can assume that. Why? Because we know that this and this is equal, this angle between them is equal, the side two are equal. So that's what it is. That's what it means to say that when we say two triangles are concurrent to each other. And the rules are that SAS, ASAS, ito rule hindi na thado to show that two triangles are same, exactly same as the rule one. What we need in order to show that two triangles are concurrent, ito nga sa rule one. Which number? Our next thing, very important one, is that when you are showing concurrency, when you're writing concurrency, okay, you're writing ABC, triangle ABC, right? Triangle ABC. So you're going like this: A, B, and C. You wrote A first, next B, next then C. So when you're writing the other triangle, the name of the triangle, you cannot write like this PRQ. You cannot write. You have to go the same exact way as this triangle went. You cannot start with R also. Since angle A and P is equal, A and P is equal, so A and P are on the same location, right? And I've already told you this angle Q and B will also become equal, even though we don't know the measurements. So B and Q is together. The equal ones are together. Even the lines AB equal to PQ na. So see, AB is the first two, PQ is the next two, like that. Okay, at last we wrote AC equal to PR, so AC equal to PR. It should be like this, okay, like exactly in order. Otherwise like not, it should be in order. So you have to know that also, how to make it in order also. Got it? As ASA concurrency rule is like if the triangles are there, okay, let's say this is 60, this is 70, then this is 60, this is 70, and the angle side angle let's say this is 5 centimeter, this is 5 centimeter. See, if you have two triangles like this where two of their angles are equal and this one side is also equal, you can say that these two triangles is also exactly the same only. Got it? It's exactly the same only. So here you can write, if this ABC, just to make you understand what it is, I'll just write like this, okay? So if I write triangle ACB is concurrent to triangle PQR, okay? Don't like angle A and P is same, C and Q is same. C is in the middle, Q is in the middle, like that. This is called ASA. Why? Because the side is in the middle and the angles are on the side is in between the angles. Side is in between the equal angles. That's why. Okay. Now AAS concurrency also works because suppose these two same. I'll just talk about these two. Okay. Same triangle. Okay. And the 5 centimeter is here, 5 centimeter is here. But instead, if it was 60 and this one 70, if this was 60, not 70, let's say 50. If this was 60 and this was 50. See, the thing is, here the side was in the middle between two angles, right? Here the two angles are not, the side and the two angles are not matching up right now. The two angles are on that side and the side is here. But even if the situation is like this, we know that in a triangle, sum of all these angles will always be what? 180 na? Angle thing there will be 180. So if we use that and say this is x, okay, let's say this is x. So if we say 60 plus 50 plus x equal to 180, so x will be equal to 180 minus 110, x will be equal to 70. So this we can find out and make it 70 also, which means it's the same triangle. See, 70 70 70 70. So now we can use SAS also here, now that we found out 70 70. So which literally means that even if these two angles are equal, we can safely say, since the third angle will also be equal, we can say that these two triangles also concurrent without the need to find this out. Got it? So even like this rule works. AAS, angle side. The side doesn't have to be in the middle. But for this one, this will not work. Okay, this will not work. The angle has to be in between the sides. Angle though, side angle has to be the included angle, otherwise it doesn't work. But for this one, it's quite flexible. You can even do SAA, doesn't matter. Got it? So that's 7.1 revision. We'll do 1 or 2 questions from 7.1 and then tomorrow we'll revise 7.2 again. I hope, or if you don't want me to make if you just want to go to the next chapter, we can go to the next chapter also. I'm just doing this because I feel like most of you did not understand properly. So if AC bisects BAD, if AC bisects BAD, so what do you understand by the term bisect? Bisect means dividing an angle into two equal parts, okay, which means BAD is the whole thing. So BAD though, pura does BAD. This whole angle is called BAD na. And if AC bisects means it's dividing the angles into two equal angles. So if the whole thing, this whole thing BAD, the whole thing was, suppose, let's say 80 degree, then we drew AC in such a way that this is 40 and this is 40. Which is not divide the angle. So if AC is the bisector of BAD, it literally means that angle BAC and is equal to angle DAC. So we have one angle, equal angles. In the question, they have already given us AB equal to AD. It's in the question, AB equal to AD. But that's it. They did not mention anything else, right? But as I've explained here, we need at least two sides and an angle in between, or two angles and a side in between, or two angles and a side, right? And but which means three stuffs we need, but here we found only two. So what is the third one is called common. Okay, so this triangle, the top one, and this triangle, the bottom one, are sharing the same side. One of the side is being shared among them, right? AC and AC. If I draw this triangle separately, and if I draw this triangle separately also, both will have AC, and both AC same as the measurement to equal. What is going to be? So AC is equal to AC is the same side. So in this triangle and this triangle, let me redraw it here. A, B, C. So, and while I'm drawing this one here, I'll flip this and draw it here. Okay, so that we can write the names properly. This part is not necessary. Okay, this part that yadi answer kotong kuri dibo paro to. Ulibi mo ini tonge kina nam likha do na jani jabo itu one idea dikhaya tonge. So after I write this, okay, if I draw, after I draw one of the triangles, when you're drawing the other triangle, what you're not gonna look here. You're gonna look at the same stuff. Okay, so we said angle BAC and DAC are same. So BAC is this. So next is DAC. So DAC. So you have to draw it like that. That way we know that AC and AC is same, and then AB and AD is same. So now we can say triangle ABC is congruent to triangle ADC. So ABC, I went like this, ABC. So I can also go, I have to go exactly as an ADC. Got it? And by what rule? One of the side, this is a side, this is an angle, and this is a side. Side, angle, side. SAS. Okay? So it will be SAS. Let's do one more question, two more questions. So in these two triangles, they're saying they've given us the side is same, this and this measurements. They gave us the measurements, so AB and PQ are same. Now they've given us angle A, they've given us angle P, which is also same, but the third angle is not same. See, but they this is 64 though, and this is 50. 66 from is not the same as there, but then this is 64 and this is 50. But like the question we did before, we can find the third angle also. So we're trying to find the third angle for both cases, or maybe one of the triangles, and let's see. So in triangle ABC, all these calculations you should be doing it in your head or in a rough section, okay, not in the answer, because you're just going to be ticking the correct answers. In triangle ABC, angle A plus angle B, 180 degrees. Now, so angle A is 66, angle B is 64, and angle C we don't know. So 66 plus 64 is 130. Angle C is 180 minus 130, which is 50. So we're getting this as 50, which means this and this is also same. right? So even if we do for this triangle and not this triangle, even if you do it for this triangle, you will get this as, if you do the same routine, okay, you'll get this as 64. So all the angles are same. So which means now I can use angle side angle or angle angle side also, depending on what the option is given. So angle side angle, angle angle, side side, angle angle. See, don't get confused by this, okay? Because angle angle angle, you cannot use it to prove a concurrency. So in a question, in yeah, they might even make a question from there also. Which of the following concurrency rules cannot be used to prove that two triangles are concurrent? They might give you options, and it will be AA, because AA we cannot use it to prove two triangles are concurrent. Why? Because in an equilateral triangle, okay, if I draw a big equilateral triangle and a small equilateral triangle, no matter what the measurement is, now the angles will always be 60 degrees for any equilateral. So it will be same measurement, okay. So the angles will be same, but the measurements will be different. So we cannot use AAA for concurrency rules. You have to understand that. Very important point. Okay, that's one last question that will be done. In triangle ABC PQR, so let's just go ahead and draw ABC first. See, I told you whenever you're you know things are equal and you're trying to draw the two concurrent triangles, to name it properly, you have to write the names of only one triangle first. Okay, second triangle and then according to what the equals are, you have to put according to that. So angle A is equal to angle R, so you put an R here. A is equal to R. AB, which is this AB, is equal to QR. So R is already here, so we need Q. So but AB is this side, so which means Q should be here, which leaves us with P. So P is here. So AC, this will automatically match up. See, AC equal to PR. Got it? So how is triangle ABC concurrent to PQR? So ABC is like they're going in this direction, ABC. So here also it should go like this, QRP. So where's QRP? Oh, not QRP, sorry, RQP. ABC, RQP, which is the fourth option. So that's how you do it, okay? 7.2, I'll try to make, or in case you want. Otherwise, we can start chapter 4 right away.